Okay, so notes today are on the fundamental theorem of calculus. And remember that we've been working on definite integrals. So the theorem is that when you integrate a to b f of x dx, you get capital F of b minus capital F of a. Okay, then remember that capital F stands for the antiderivative of lowercase f. Okay, capital F is the antiderivative of lowercase f. So we're just going to jump right into an example. Look at number 1. It'll be the integral from 1 to 3 of 6x squared plus 1 dx. Okay, so your first step would be to take the antiderivative. And for the notation here, you would, once you take the integral, you're going to put brackets and then do your power rule on both of these guys. So remember, I'm going to add 1 to my x squared. It makes it x to the 3. Then I take that 3 and I divide it with the 6. That gives me a 2. Okay, plus. Then remember, the integral of a constant like 1 would be 1x plus c. Then you're going to plug in capital F of 3 and capital F of 1. Okay, so I'm going to plug in 3 first. Okay, 3 plugged in here is going to be 2 times 3 cubed plus 3 plus c. 3 cubed is going to give me 27. 27 times 2 is 54 plus 3 plus c, which is 57 plus c. Okay, I'm going to give myself a little more room here and move my f of 1 down. Okay, f of 1 is going to be 2 times 1 cubed plus 1 plus c. 2 times 1 cubed is still just 2. 2 plus 1 is 3, so this is 3 plus c. Okay, once I find f of 3 and f of 1, okay, my theorem says that I'm supposed to do f of b minus f of a. So I'm going to do the top expression minus the bottom expression. And then remember that since you're subtracting the entire 3 plus c, I'm going to distribute that into my parentheses. So really, I have 57 plus c minus 3 minus c. And at this point, my c's are going to cross out. So really, all that's left is 57 minus 3, which is 54. Okay? Alright, take a look at another one. We're going to do number 2, which is the integral from 2 to 6 of x minus 7 dx. Okay, antiderivative of x, I'd add 1, so it'd be an x squared. Then I have to divide by 2, so it'd be a 1/2 minus 7x plus c. And then remember that when it's a constant, like a minus 7, you just add an x to it. Okay, then I'm going to find f of 6 and f of 2. Remember that you want to use capital F's there because you're plugging into the antiderivative. So it'd be 1/2 6 squared minus 7 times 6 plus c. And then down here it'd be 1/2 2 squared minus 7 times 2 plus c. Okay, I'm going to do the 2 one first just because it's easier. So 2 squared here is 4. Half of 4 is 2 minus. 7 times 2 is 14 plus c, which means that this is really negative 12 plus c. Alright, top one. I have half of 6 squared is 36. And then minus 42 plus c. Okay, and then half of 36 is 18. And 18 minus 42 is going to give me negative 24 plus c. Okay, then remember from here, I want to do capital F of b minus capital F of a. So that would be capital F of b minus capital F of a. So that would be negative 24 plus c. minus negative 12 plus c. And then remember, you can distribute, so it'd be negative 24 plus c. Minus negative 12 is a plus 12, and then minus on the c. Then my c's are going to cross out, and really all I'm left with is negative 24 plus 12, which is negative 12 is your answer. Okay, now if you remember, we've been talking about over the last couple of weeks that an integral is area. So when this comes out negative, it's kind of confusing because you would be wondering, well, how did the area come out negative? Okay, let's look at the graph for both of these functions. Okay, if I'm looking at the graph for number 1, we're just going to do a little sketch here. 6x squared is quadratic, plus 1 shifts it up 1, so there's your graph. And then if I were to shade from 1 to 3, okay, that's the area that would have been shaded on your graph on that interval. Okay, now let's look at this one. Okay, x minus 7 would start, remember that this is the y-intercept. So if I go to negative 7, we'll say that's down here, my slope is a 1 over 1 in front of the x. So it's going up and over, up and over, up and over. And then I'm shading from 2 to 6. Well, if this is a negative 7, then this is a 7 as my x-intercept. So the reason that it comes out negative is because from 2 to 6, my area, okay, is all below the x-axis. And so remember that your integral is directional area. And what that means is that your 24 units are below the x-axis. Okay? Alright, another one just like that, please. We are going to do the integral of sine x from 0 to 2 pi dx. Okay, so let's start off by taking our antiderivative. You can snow cone if you want. Okay, so if I'm up here at sine x, that's a positive sine x, and I go up 1, that puts me at negative cosine in the box. Okay, then I'm going to find f of 2 pi, then I'm going to find f of 0. Let's do f of 0 first. That'd be negative cosine of 0. But then the cosine of 0, remember that that's a 1. So cosine of 0 is 1, then it's a negative 1 for your bottom. Okay? Now let's find it for 2 pi, negative cosine of 2 pi. And then if I think about on my unit circle here, 0's here, pi is over here, 2 pi puts you back on the exact same spot that you were at for 0. So when I do 2 pi with my hand trig, I'm actually going to use 0 as my reference angle. And then remember the cosine of 0 is 1, so this is also a negative 1. Okay, when you put those together, you do not get negative 2. You would have negative 1 minus negative 1. Well, then really, these are going to be added. And if I do negative 1 plus 1, that gives me 0. Okay, now remember that your integral stands for area. So it doesn't make sense that I have no area on sine. Let's think about what sine looks like. Okay, little skinny graph here. Sine starts at 0. Remember that it goes up, and then it goes down, and then it goes back up. And then at that point, think about both of your area pockets. What? I don't. I'm almost done with this, though. These guys are going to cross out with each other. And so since they're the same size, that's why it came out to 0, is because this area up here is positive, this area down here is negative. You're coming back 6. Okay, cool. Okay? And so then these areas are going to cancel out with each other. That's how come we got 0. So just remember that just because your integral comes out to be 0, it doesn't mean that there was an area. It just means that the area on top and on bottom was equal, and so they canceled out. Okay, next one, number 4. Okay, number 4 is going to be the integral of 3 square root x, 4 square root x cubed, and it's going to be from 4 until 9 dx. Okay, so the first thing that I'm going to do is take my antiderivative. Remember that, actually let's rewrite this. Okay, this is a 3x to the 1/2, because remember x to the 1/2 and square root x, those are the same. Okay, then plus 4. And then my x here is going to be to the power of 3 with the square root, makes it a 3/2. Okay? So I want to rewrite it like that so that I can do my power rule. So remember, for the power rule, you're going to add 1. Okay, well, I'm going to think about 1 as 2 over 2 for both of those. So if that's a 1 over 2 plus a 2 over 2, that gives me x to the 3 over 2. And then remember that after I add, I have to divide by that new number. So if I'm going to divide by 3/2, I'm going to just multiply by 2/3. And then remember in front that I also had a 3 out there. So those are going to combine here in a minute. Okay, then plus 4. Then here I have a 3/2 plus a 2/2 is an x to the 5/2. And then if that's a 5/2, then I'm going to have to divide by 5/2, which is going to give me a 2/5. And then your 3's there are going to cross out on that first one. So 3 and 3 are both gone. That gives me a 2x to the 3 square rooted plus 4 times 2 here is an 8 over 5. And then x is going to be to the 5th and then square rooted. And then from there, I'm going to find capital F of 9 and capital F of 4. Okay.